Well, hello. In this module, we're going to talk about security requirements. In the prior modules, we built up to this. So we talked about threat models, we talked about attack trees, we talked about abuse cases. Ultimately, all of these are coming together so that we can develop a set of security requirements for the system. So what does security requirements address? You want to proactively address negative events that may happen due to an attacker. You want to describe how the system should respond in light of that negative event. And then, be pondering in that point, who is it that would be threatening the system and what would they want to do? So one form of security requirement is a functional security requirement. This type of requirement is specific functionality that you build in the system that provides added security. For example, this is saying that back office users have to authenticate with their user ID and password. So because that's a functional requirement, you implement that functionality. You can also have non-functional security requirements. These are, so any non-functional requirement is an emerging property of the system that actually could apply to almost any of the requirements themselves. Here's an example. Audit logs should be verbose enough to support forensics. That's a type of non-functional security requirement, and every functional requirement to fulfill this non-functional requirement may have to have a little bit of added functionality to adhere to this. So you have a functional requirement that says the doctor can edit a patient record. Part of that functional requirement says you need to be able to audit it, and you need to be able to have that audit message be verbose enough to enable forensics. So a non-functional security requirement is an emergent property of the system that you have to consider when you implement each functional requirement. The final category that we'll talk about are implied security requirements. And these, you take a functional requirement and then there's an unstated second half of it. In this example, the example is that if people have more than 5 attempts at logging in, that you want to take away access and lock the account out. The reason to have a requirement like this, which is a stated functional requirement, is because you don't want to have the ability for a bot or some kind of a script to do a dictionary attack and repeatedly try user IDs and passwords until they actually are able to crack the password. In this case, after 5 attempts, then the account is locked, and then you're disabling the ability to launch that type of dictionary attack. But think about it for a moment. What could go wrong if you lock out accounts with 5 failed attempts? Think about what problem might happen. If you think about it for a moment, you could see that an attacker could cause a denial of service. If an attacker wants to take away access to a user, they'll just try their login 5 times and then they're locked out. An attacker could actually, if he or she learned the user IDs of a whole office, they could develop a script that tries for each person in the office logging in 5 times incorrectly and then locking the whole office out. So you need to protect from that implied denial of service threat and build in some type of functionality, such as is recommended here, that after 5 minutes of being locked out, the account is enabled again. So what this is to say, you need to be thinking about the implications of the prior security requirements and can there be a problem with it. Another input into the security requirements process is the security policy of an organization. So an organization should lay out all of the policies for data sharing, for data storage, a number of different things. And what you have to do is take a look at the security policy that you must adhere to for the application and make sure that the application actually adheres to the policy. And so the policy is generally not something that the users of the system will state in their functional requirements, but you need to make sure that your system adheres to it. Another effort that I'd like to talk about is actually something that one of my own graduate students worked on. And this is really knowing that, that developers focus on the functional requirements, the stated functionality that users will say they want in the system. What you see here is an example. So HCP, which is healthcare professional, can return to an office visit and modify or delete the fields of an office visit. So that's a functional requirement. A developer could just implement that functionality. But what my student developed was a system that would look at the words in a functional requirement and, based upon patterns, identify what security objectives that need to be adhered to because of that functional requirement. Based upon the types of things that she developed is some implied functional requirements. So in this case, the first one deals with authentication, identification and authentication. And so what this is to say, in order to properly and securely implement the main functional requirement, that you need to make sure each user is assigned a unique identifier and must authenticate into the system. Confidentiality. Any of the data that is in this office visit needs to be protected and be held confidential. Integrity. That the data in this that's saved in this office visit cannot be changed without understanding who changed it and having an audit trail so that there is high integrity of that data. Accountability, so every time this functional requirements happens, there needs to be a trace of it so that the user who did the office visit can be traced back to the action that they took. And finally, the user, the owner of the data needs to be notified when the office visit is modified or deleted by the healthcare professional. And so what really the work that she was trying to say is that while developers focus on the functional requirement itself, you need to keep in mind all of the other dimensions of security and make sure that in order for that functional requirement to be implemented securely, that you are considering all of the dimensions. And her work shows patterns that can help you to do that work. What this slide talks about is all of the different inputs into actually a comprehensive set of security requirements. If you look at the right side of the screen, there are some common best practices such as information technology, legal, audit, policy, as we talked about, development, operations, QA, and testing. All of these are best practices that may inform some aspect of security requirements. On the bottom part, attack patterns, so just understanding the way that an application like yours has been attacked in the past, what kind of vulnerabilities have been attacked, what are some historical risks in the past. Those are input into your security requirements. Up at the top, we've talked about abuse cases and attack trees. What you'd like to do is to create the abuse cases and the words that go around the abuse cases, as well as the attack trees and the prioritization that can happen in the attack trees, and consider all that. So those were the last few modules, and you want to take the input from that and put it into your security requirements document. And finally, on the bottom, architectural risk analysis. So we went in detail through threat models and the types of things that you need to implement into your system so that you can implement your system securely. So all of those are things that you would consider, and then ultimately from that, develop a comprehensive set of security requirements, functional requirements, non-functional requirements, and implied requirements that you would implement your system so that it would be implemented properly. Here's just to summarize, it's never too late to start on security requirements. I will admit that in my communications with companies, often the set of security requirements is not there, or they're just kind of template security requirements that you copy from one requirement document to another without really understanding them. There's not a really great state of the practice with the development of security requirements. So you may be thinking, how are you going to go about this? But the main thing is to get started today, start to use some of these techniques and develop some security requirements for your system.